All right, thanks everyone so much for joining us. My name is Steve. I'm part of the AWS account team. It's my pleasure today to present Mike McGrath from American Commercial Lines and Thuro Saidogaipan from Apps Associates. Thank you so much.
A quick intro.
Yep.
We're here to talk a little bit about our EBS migration from sort of a traditional colo data center arrangement with a managed services provider over to another managed services provider using the Amazon cloud as its infrastructure platform. A little bit about our company. You won't find a whole lot of the buzzwords that you hear in the other sessions today, things like Hadoop and NoSQL databases. It doesn't really fit the use cases in a business that moves commodities in barges. The best I could come up with was that we move commodities at scale. So just as an example, the boat and those barges, that's pushing maybe 40 barges. Each one carries about 1,500 tons of commodities. And the surface area out in front of that single boat is about 2 acres. So it's an interesting operational business, but not one that necessarily gets to play with the latest and greatest technology. Prior to our AWS migration, we were relatively new as EBS customers. We went live with release 12.1.3 in February of 2013. Of course, that project went off flawlessly, right? So by the time we went live, we were already 2 years into our hosting agreement. That was initially a 3-year agreement with our existing managed services provider. So as that 3 years came up for renewal, we began to look for other options. A little bit about our footprint. We run eBusiness Suite as it is a mission-critical application for us, but it doesn't run the operations of the business. We don't run contracts through there. It doesn't dispatch our boats and barges and our crew. But we do use, of course, core financials, purchasing, inventory, asset management for our boat maintenance. Our user base is largely at our headquarters location outside of Louisville, Kentucky, but we do have users in facilities in New Orleans and St. Louis and a couple other locations. EBS also integrates with some on-premise systems that we've got. We're Oracle customers in a lot of different areas. Another one is, of course, the Identity Management Suite. So we use Oracle Access Manager as the single sign-on product. It's integrated with Active Directory and provides the SSO solution for EBS. I mentioned already we were 2 years into that 3-year agreement when we went live. We were happy with the managed services provider. They provided us good support for the time that we were with them. But we had some other things already going on with AWS. We ran off and on a couple Microsoft servers, Linux servers for various small tasks. We use Route 53 DNS. We had recently hired intentionally someone into our infrastructure team with AWS experience. And looking down the road, we have a likelihood that we'll adopt some software as a service applications that actually deploy only to AWS. And so in piecing together our footprint and not really wanting to continue investing in an on-premises data center, AWS seemed like kind of the logical place to go. Some of the reasons that became kind of the obvious choice for us were some of the things you heard in the keynote today, right? Its platform is mature. It offers a lot of features. It's affordable. Particularly appealing to me is the pay-as-you-go aspect of the AWS platform. For example, our project in converting over didn't require upfront CapEx in hardware. You didn't have to buy all that hardware at once. We had some luxury with taking our time with the dev, test, and prod migration. So we didn't even have to pay for the hardware running the prod systems until we were ready to go live with them. I just really like the flexibility that brings both budget-wise and in terms of scale and platform fit to the services that you're trying to deliver. The project for us in migrating to AWS began with a partner selection. And we did compare, at the same time as an AWS-based solution, other colo solutions and another service provider. We talked to one service provider specifically about, could you host this on AWS? And as a managed services provider in the Oracle EBS world, they said, sure, we can manage an Oracle EBS environment on any hardware. And I think that to some extent is true. But in the end, we chose a partner that specialized both as Oracle EBS implementers and as an AWS partner. And I think that's really important. You'll probably hear why in the next slides when Thiru comes up. AWS has a lot of complexity, and you could just spin up a few servers, but to actually make it run really well, be cost effective, be reliable, you do need the expertise of knowing the AWS platform, how to make that architecture run EBS well. Our project itself spanned about 3 months. We had a dev implementation or a dev migration that went very smoothly, very quickly. We had that instance up and running. It gave us plenty of time to get our feet wet with it, see how it behaved. You know, we were kind of experimenting with a lot of things there, both the connectivity to the AWS cloud and the performance of the footprint we had deployed it against. So once we were content with that solution, we then migrated our test environment over, and at that point got our users involved in some testing and ultimately went live with production. Total of about 3 months. The production downtime migration was only about 4 hours for us. We don't have a large data footprint in EBS. That's a big piece of that. But in the end, the Apps Associates team cut that data over, moved it into the AWS cloud across our internet connection, and brought the instance up, and it went pretty well according to plan. We had a few issues with the single sign-on environment, which really just had to do with the intricacies of Oracle Access Manager, but we resolved those quickly when we went live, and it really didn't cause any trouble. This project for us was very IT-centric. People tend to not want to mess with your EBS environments or your ERP environments generally, but the timing was right for us to make this change. And from a user perspective, aside from a couple hours of testing over a weekend with the final production migration, didn't really affect them a whole lot. So we're really pleased with the way the project went. Now for the actual good stuff and the details about what it took to pull this off and how to manage an EBS environment, I'll turn it over to Thiru from the Apps Associates team.
Thanks. Thank you, Mike. I appreciate it. So good afternoon, everybody. My name is Thiru Saragopan with the Apps Associates. What I wanted to do was to, let me make sure I have this right. Perfect. Sort of look at some of the technology considerations for how you would want to move, specifically here in Oracle E-Business Suite or Oracle ERP solution, but it's going to pretty much hold true for any of your packaged applications that essentially is a combination of your database platform and your application server platform. The focus here or the goal of this presentation is to show that mission-critical applications such as this can be run on AWS, and what are some of the operational considerations that typically go with these kinds of applications, and how would you address them specifically on the Amazon Web Services platform. So I kind of chose these 5 or 6 bullets here, starting from how are you going to get connectivity and access to the environment to the different tiers, applications, and databases. Storage, we'll spend a little bit more time specifically to understand how you would choose the specific storage configurations, because that is a very, very important piece of the performance that you require for these kinds of applications. So before I dive into this, I just kind of wanted to get a sense of the background of the audience here. So how many of you are actually running an Oracle ERP solution in-house for your business? Great, okay, that's quite a few, all right. And how many of you are technical administrators in the sense, DBAs, apps DBAs, system administrators? A few versus I'm going to assume the rest of you are more associated with the business aspects and own the application stack in terms of the functionality you provide to the business. Great, thank you. So let's go ahead and start with the network access, right? Virtual private cloud, pretty much everything that we're going to do, on AWS is going to be inside the virtual private cloud construct. Essentially, it's a network layer that provides a isolated space on the AWS infrastructure that's going to ensure that the access to that environment is only going to be through your existing network or your established connectivity for the environment. We definitely use a public subnet and a private subnet configuration in the VPC. As some of you may know, VPC allows you to kind of have only public or only private. There are combinations here. The reason we would want to have a public subnet is that there are sometimes public-facing modules that are part of the business stack, such as iRecruitment or iSupplier, that essentially is open to the public, and your customers and your suppliers will access them. Reverse proxy is often also used so that you don't have to expose your Oracle software stack in the DMZ. Keep the Oracle software stack inside, just use a reverse proxy on the outside. Connectivity to the AWS platform often comes into question. Customers would want to know, do I get the leased line circuits, MPLS, and bring direct connectivity to the environment? Or can we use SSL-based IPsec tunnels? In the traditional hosted environment, we see both of them, right? When you're leveraging traditional data centers, extending your MPLS and your network to that, whether the lease line or IPsec tunnels. We find that IPsec tunnels are quite capable of giving you the performance that you need from the network aspects of it for running these kinds of business applications. We also have customers that are running BI solutions on AWS, whereas the ERP stack sits inside the environment and they're able to connect it over the WAN. ETLs can run over the WAN and they're just fine, perfectly fine. Having said that, quite often with the success of these kinds of deployments, the adoption of the AWS platform do expand within the organization. There are more and more workloads that could come in. So it always allows you at some future point in time to maybe go down the route of using direct connect and establishing that leased line circuit. But SSL tunnel will go a long way. Let's take a look next at what are the different instance types and Amazon machine images you would want to choose for your Oracle ERP deployment, right? So as we know, there are that's a database tier and multiple application tiers over there. These kinds of applications are memory intensive. It is an important characteristic of performance configurations for these kinds of business applications. So you would definitely be looking at, depending on where you are with the number of cores that you think you need it and you're licensed for, especially in the Oracle technology stack, quite often different licensing schemes will be around the number of cores that you could deploy. So you'll find the correct instance type. Amazon has quite a bit of instance types to offer. We tend to see that the high memory instances will typically be used. There is one caveat here that certain versions of the Oracle ERP stack, the 11i stack especially, is only 32-bit for the application stack, whereas the database can, of course, be 64-bit database. 11g databases is the latest certified versions. If that is the case, then we really do have to do a lot more work in helping an application stack configured for 32-bit because of the fact that you can only get one core and 3.5 gig, I believe, 3.5 gig of memory for those instances, which makes it really difficult to run a full-blown applications tier. So we look at multiple application servers and load balancers in front of them to be able to configure those kinds of applications. In this case, with American Commercial Lines, it was the 12.1.3 version, which is full 64-bit compatibility for both the application tier and the database tier. So we certainly didn't have to face that challenge here. But we certainly do have other customers who are running 11i e-business suite, and we have to work through it. Oracle Linux and Red Hat Linux are pretty much what we use when we're considering hosting Oracle e-business suite for various organizations. SUSE Linux and Windows are also part of the certified stack of operating systems that Oracle ERP is certified for, but we find that these two operating systems are pretty much mainstream, pretty decent support, and you're going to find fairly decent support for these environments. I have a note in here for para-virtualization versus hardware virtualization. That's an important consideration because once you go up the instance types in terms of the number of CPUs and cores, some of those instance types only supported with HVM, whereas the Oracle Linux as an operating system is only PV compatible as it's available right now. So we find that we would want to use Red Hat Enterprise Linux for some of those larger instance configurations. On the other hand, the cost of the instance type is lower for the Oracle Linux AMIs that you would use. So it's a balance between what really fits your business and where you think that you would want to be in terms of the configuration that you, first of all, are accustomed to, used to, and depends on your application size. So moving on to the next item, database and application tiers. So for large environments, for performance characteristic, number of transactions perspective, the database tier is, servicing quite a bit of both transactional workloads and systems such as an ERP system is quite not kind of standing by itself in the middle of your application footprint. There are quite a bit of integrations. A lot of your other applications, be it business intelligence or be it HR kind of integrations or supply chain integrations, EDI, there are quite a bit of things that are all usually around it. So the database always tends to be intensive application for which you do have to look at some large instance types or memory configurations. Whether it is an application tier or the database tier, our best practice is to make sure that you're using the same exact version of the operating system. When you're starting a journey for the Oracle ERP stack in AWS, you would choose the AMI for Red Hat Linux or Oracle Enterprise Linux, apply all the different RPMs and packages that brings you up to your certified levels for running your Oracle ERP stack, and then you use this beautiful function of machine imaging it, calling it AMI, and then spawn them as you need for your test, dev, production deployments as you go forward. Right now, we typically deploy just one database server on the AWS platform because of the fact that the storage that you would assign, the EBS or the elastic block storage that you assign can only be attached to one instance at a time. Whereas if you're looking at running multiple database tiers with the common storage that you could do, typically be connecting to enterprise SAN. In AWS, I'm sure that will be a new feature that will be coming out at some point in the future. So right now, we pretty much run the database as a single node. We don't look at a cluster database configuration because the storage is usually attached only to one instance. The application node, on the other hand, we can certainly run multiple application servers, especially in Oracle ERP stack. You have the ability to segregate application tiers by forms and webs and concurrent and try to leverage some throughput based on the server sizing. So all that is definitely available, and the elastic load balancer, the ELB, that AWS has to offer works quite well, and we're able to configure that. When you're considering multiple application servers, you do have to have the Oracle binaries for the application stack available to all the nodes. So in that classic situation, clustering comes into the mix because even though you could potentially have a separate copy of the application binaries in each of your application servers, it's sort of a maintenance overhead. Anytime you're patching and making changes to it, you got to replicate those changes in all these environments. Whereas with the shared application file system technology Oracle has introduced quite a long time ago, allows you to just maintain one application file system that is used by all of the application tiers. They will have their separate directories for instance-specific or node-specific configuration files. So in that case, you will probably want to look at cluster file systems or NFS, depending on what you're looking at, so that all the application tiers have access to the file systems. Okay. I think the format that we're following for these reInvent sessions is that we're going to go through the presentation, and then we will have time for questions and answers at the end. We do have actually another gentleman, Mitch, from American Commercial Lines, who's been involved with the deployment along with Mike McGrath here, who can answer some questions for you based on their experiences, as well as a couple of solutions architects from Apps Associates who are here, who are also involved with the deployment. So more than happy to answer any questions that you may have at the end. So let's keep moving here. Enterprise storage requirements. Whether it is an ERP platform or large BI platform, you would typically be looking at these 4 categories: performance, durability, and availability of your storage, the cost, elasticity. I said I want to talk through what those considerations are and then talk about how will Amazon Web Services platform help you meet those objectives and where it could potentially perhaps even be better. Right? From a performance perspective, from an enterprise SAN level, you're looking at some really high performance, low latency. Typically, you're looking at flash and SSD and different kinds of storage technologies to address that. For availability and durability, different RAID configurations that are pre-built within the SAN environments, or if you're using direct attached storage, things like that, you have various ways of configuring RAID technologies for that. Typically, in the traditional data center environment, you're purchasing the equipment up front, so it's upfront CapEx cost, and then investing in it, and obviously leveraging to the best across different applications in your data center. And anytime you need to expand or add more or temporarily launch some test environments to support some project requirements. You're usually adding more, buying more disks, or you have a large design investment that has the capability or capacity to handle it, essentially over-provision to begin with. Let's look at what that really translates to in the AWS world, right? From a performance perspective, there are the elastic block storage as your basic building block for block-level storage, combined with PIOps, what is provision IOPS, that lets you configure your storage environment for the IOPS that you think is required for your applications based on the analysis, right? For provision IOPS, AWS has a guarantee that it is, the exact parameters the gentleman here would know, but I think it's something like 99% of the time it's going to give you 99% or more of the IOPS that you have provisioned for that environment. So that's going to be a very, very key aspect of how you configure the storage for an Oracle ERP system because of IOPS in the mix. Durability and availability, snapshots, the ability to leverage S3 storage, which is, as most of you know, 11 nines of durability, and offers you the ability to rely upon that data. It's replicated across availability zones, and you also have the ability to replicate your S3-based backups and snapshots, I'll talk a little bit about that later, to another region, so that you can have sort of the building blocks for a DR environment, if you choose to. We'll talk a little bit about that later. Cost is pay for what you want. If your database requires 800 gigs and you're going to configure 1 terabyte, that's all you're going to start with. If it's growing at 100 gigs a year or 200 gigs a year, whatever, you would add storage when you need it. You don't have to provision ahead of time. So it's purely pay for what you use. If there's any dramatic increases because of acquisitions, mergers, additional modules being deployed, any big jump in spaces, just go in and a few clicks over the console and you get as much storage as required. That's a very powerful feature of these cloud computing platforms, specifically Amazon Web Services. And elasticity and scalability, of course. We can add storage when it's needed or deprovision storage when you don't need it, and be able to allocate and deallocate fast and quick, really agile to meet the business needs. Summarizing all of this, and by the way, this presentation is going to be available on the AWS website, so certainly you'll have full access to this. To kind of summarize it, let me look at this a little bit closer as I speak to this. We are classifying on the column, the different rows, the different storage components Amazon has to offer across Glacier, S3, elastic block storage, and as well elastic block storage with PIOps. And then, of course, the instance store, which is the storage that's available as part of the instance type when you provision it, but it's ephemeral, meaning when you stop and restart the instance, that particular storage data on that storage is going to be lost. So we definitely will not be using the instance store for any kind of permanent data. So we kind of looked at it across general purpose use, database use, applications use, binaries, and things like that. And then how does it map against speed and durability? So some of it is probably pretty obvious, as many of you who are looking at AWS, one of the first things you're looking at and understanding is the network aspects and also the block storage and instance types. So you sort of wanted to give you a perspective of how you would look at distributing different kinds of workloads for file systems based on what type of data they are, database files versus binaries versus backups and things like that. So let me keep moving in the interest of time. There's another slide here which goes into a little bit more data. So having given you this overview of how you would put together the various storage elements for the solution together, let's look at specifically what does an Oracle database require? How would you look at storage for an Oracle database, right? So any database is not only true for just Oracle, any database, if the data can be in memory, right, you're going to get 100% buffer hit, and the performance of your system is going to be at its peak, given what it can get out of the CPU memory configuration of your environment. So, but it's not often true that you're going to have the luxury of being able to have your entire database inside the memory, right? So this example from Oracle illustrates the fact that if there is a cache hit, if the data block that you require is in memory, the performance, the CPU time is dramatically different, right? Pretty obvious, all of us know that. But what does it really mean in reality, in today's world? Right? Data is always increasing. Database sizes are always increasing. The number of users You as the business grows, the goal for all of us is to have increased user base to support the growth of the business. So what does it mean for a database? Now, it's not possible for us to be able to cache all of the database data. The database is going to then decide on, hey, which is the most active data and configure it. And of course, as DBAs, you do have lots of great configurations and tools and techniques to create different pools in your cache and allocate which data you think is going to be most commonly accessed versus data that's least accessed. And there are tools you have always used. This is true even in the traditional world as compared to the cloud computing platform. So this is what, as DBAs, we have all done. I/O, as a result, is always there, right? No matter how much memory and how we configure and utilize these platforms, I/O is going to be a very important factor for performance of the database. And how does that translate? The reason why we're talking through this example is to look at how would you handle I/O in an Amazon Web Services platform and run these kinds of applications. This is an interesting diagram or chart from Oracle Corporation. It looks a bit busy, but let me just ask you to focus on sort of the x-axis. It essentially shows you the number of threads, right, in terms of being able to throw more CPU cores, CPU threads at it. If you increase the number of threads of CPU, and what is being shown on the left side is transactions per second, right? The vertical bars that you're seeing, you will see that more CPUs are throwing at it, you're able to get better and better transactions per second. But after some time, it's going to flatten out. And on the right-hand side, you see response times, which is being shown as that line chart. Same thing, as you are able to throw more and more CPU cores at it, your response times continue to stay low. You get better and better performance. But after some time, your response times is going to start to increase as well. What is the reason? It's because of I/O. Right? You can only do so much with more CPU, more memory we can throw at it. At some point in time, I/O is going to be the most important factor for your database performance. So what are the best practices from Apps Associates? We recommend for Oracle databases in general, whether it is an ERP system, which is a lot of OLTP transactions, or if it is a data warehousing platform or a multi-purpose database, which is very common these days, right? As Oracle ERP consumers, I'm sure many of you are probably aware of this ASM feature, as we call it, right? Automated Storage Management. It's actually available at no cost when an organization does have licenses to operate an Oracle database platform. We don't need any extra licenses for running ASM. But what ASM is actually sort of like a logical volume manager, right? So if you're going to have multiple LUNs presented from your SAN or direct attached storage, you present it to the server. The first thing we're going to do typically is that the Linux operating system file systems are going to look at those raw devices and own it and collect it, put it together into a large volume, and create a file system on it. The database then consumes the storage it requires from the operating system, right? It looks at its files and directories, and the system administrator is managing it. What ASM allows you to do is to bypass that logical volume manager layer and not have to have file system manage your storage. You present the raw devices from your storage directly to the ASM feature. It's an Oracle product. It's a product that's designed specifically for the Oracle database. So there are some great benefits that we can get, especially we're looking at how we want to configure storage for Amazon Web Services platform specifically. The second bullet here talks about striping and mirroring. So what I mean by that is, say your database requires 500 gigs. For a simplistic example, you say you're going to give one 500 gig EBS storage to it. With ASM, you can now give two 500 gig EBS storage volumes to it and ask ASM to mirror it, right? You can do that with the operating system RAID technologies as well. Or if you're going to split that 500 gigs into 5 100 gig disks, and then you can create 10 of those, and then you can ask ASM to say, hey, this is the primary set and this is the backup set, and mirror it. Even though EBS volumes at Amazon does come with a certain level of redundancy in the back, and it comes with a certain level of SLAs associated with the availability of that volume, this allows you to have another additional layer of protection if you require. So this is built into the technology. But most importantly, why we like ASM is that you may provision the storage in the beginning expecting a certain database size and certain number of IOPS, 1,000, 2,000, whatever. 6 months down the road, 1 year down the road, 2 years down the road, if there is a change and you need to expand your storage, typically with logical volume managers, not all of them are great at just being able to add more extra storage and dynamically expand the file systems and make the storage available to you. Quite often you're looking at downtimes, or we don't want to take the risk that you want to do this in the middle of the day. You would take a downtime, even though your software technology stack could perhaps do it. But with ASM, we don't have to worry about it. We simply provision the extra storage and tell ASM you have extra storage, use it, and it will actually start going ahead and rebalance and move hotspots and things like that on its own when the database is up and running, right? It's great for that, but it's also great for is that if you started off with, say, 200 IOPS for these devices, and you find out that, no, I need to go to 500 IOPS. So now you can add more EBS volumes with 500 BIOPS. But then you also have 200s in the mix, 200s and 500s, right? So ideally what we would like to do is to be able to completely take all the 200s out and add fresh 500s in and have a clean slate to start with. That requires a downtime, data copy from old to the new, and then bringing it back up. ASM can do that dynamically for you as well. You can pretty much point to the disk that you want to release and say, move the data off of these. And it's done, and during quiet time, you can go and ask ASM to release those disks, and once it's done, you simply go in and deattach that EBS volume. So it makes operation of your database platform much more easier and convenient, all with the flexibility of not having to put any high capex up front and being able to get the storage when you want. Quite powerful. The last bullet there talks about Oracle Secure Backup. Essentially, it's Amazon Web Services and Oracle has jointly worked together several years ago to add a plugin to the RMAN backup utility. RMAN is the most commonly used database backup utility for many of the platforms. So what this allows you to do is to, even if you're running a database on-premise, simply run RMAN and configure RMAN channels to be S3 storage instead of your tape backup or disk backup or whatever. So the backups are going to go straight to S3 storage from your environment, encrypted on the fly and things like that. It's quite powerful utility. So we would definitely be leveraging RMAN and secure backup as well as part of this. So to summarize a little bit of what we just talked about, given how we can leverage EBS volumes as Oracle eBusiness users, the word EBS is often, we often find ourselves talking eBusiness Suite, whereas in the Amazon world, it's Elastic Block Storage. We actually had to do quite a bit of work making sure our PowerPoints didn't use EBS whenever we talked about eBusiness Suite to make those edits. So for a database, you have binaries, data files, transaction logs. In the Oracle world, it's called the redo logs, and then copies of the transaction logs that you want to keep so that you can, if there's a failure and you're recovering from a backup, you want the transaction logs to be available to play up to the point of failure. So those are called the archived redo logs in the Oracle world. And then you have your backups, good old database backups or application file backups. This slide just talks about it in a tabular format as to what are the appropriate AWS storage elements that are a good fit for those different use cases. Right? So it's very rare that you're just going to create one EBS volume of 500 gig and put your entire database there and forget about it. Right? We do have to look at the characteristics of the different files in your database and how they're used and how they impact performance, and then be able to map to your storage elements. And that's actually going to be very key in terms of being able to configure and run these transaction systems that require very sensitive performance. Now, what's also there in PIOps, I'm not sure how many of you know what is behind the SLA that AWS provides when you say you create a EBS volume and then you say you want a specific PIOps to it. You can go up to 4,000 PIOps unless, Ravi, they have increased the PIOps recently. I think 4,000 is still the maximum, right? So what really happens is that the moment you associate a PIOps disk to an instance, they're going to have a separate backplane for the I/O traffic. Right? It's like a separate network, segregated network, as opposed to all the other networks where your client activity and application activity and those kinds of activities are going to be happening. That's one of the elements. To be able to take full advantage of that, it's also very important to make sure that the instance types that you're choosing are what are called EBS optimized instance types. Many of them are EBS optimized, but you do want to make sure that the instance types that you're choosing are EBS optimized so that when you're using PIOps on your EBS storage, you're actually able to take full advantage of that. In fact, the SLA associated with BIOps is only applicable if you're using EBS optimized instances. Okay? I do want to spend a little bit of time with this because I think this is a very key element of your success of being able to deploy Oracle E-Business Suite or any kind of ERP solution, a database platform. A couple of sort of pictorial representations of what I just talked about. Here is an option where you're showing 4 1,000 IOPS volumes for the database, so you get 4,000 PIOPS for the set. You can have ESM manage it, and then you configure what is called the flash recovery area, which is where your transaction logs or archive redo logs are going to go. And typically, non-production environments don't need that same capacity, so you probably have lesser IOPS, or you probably combine multiple database platforms on a same set of disks. Here, this example shows that we're using the Oracle Secure Backup functionality within RMAN to take the backup of your database to S3. It goes directly to S3. And of course, you can use lifecycle policies to leverage Glacier as well if required. Sort of the summary of what we just discussed. But let's take a look at backup specifically. We're talking databases in hundreds of gigabytes or multiple terabytes these days, right? So how would you approach database backups for those kinds of platforms? One of the ways that Apps Associates, we recommend that we look at is to leverage RMAN as your backup utility. So it's going to take your database copy, right, off of your primary EBS volumes that are running your Oracle database at that time, and let RMAN take the backup and send it to a separate file system, which is also sitting on EBS, perhaps lesser PIOPS, is only a backup destination. It's sitting in a separate file system, and then snapshot that file system. Right? The moment you snapshot that file system, it's going to go to S3. So you can time your snapshot to your backup timings so that you have a full backup available sitting on the file system. So if any kind of a localized failure that you need to do for recovery, you can grab your full backup sitting right there on your file system. Right? We don't have to go back to snapshots and recover it and make it create your entire business volume back and then go after and get it. The larger the file system, the larger the database size, the more time it's going to take for you to recover your primary file systems from your snapshots. Second is if you're also trying to snapshot a bunch of EBS volumes that are put together to create the database file system for you, the snapshot has to be completely synchronized across all 4 of those. So they're taking the snapshots at the same time. Where the snapshot feature today is EBS volume by EBS volume. So it also puts some challenges in terms of working with that specific technology, how are you going to do this. So that's one way of doing this. The advantage, as I said, is that there's always a copy or 2. We typically size the backup file system so that it can keep 2 or 3 full backups on disk. A nightly full backup is sitting there. So when you need a copy of your production data to create a test for cloning and things like that, it's readily available. Right off of there, you can take it. We don't have to go back to snapshots unless there is really some kind of a major failure that's forcing you to go back and do some serious level recoveries. Okay? The other option is use RMAN to go directly to S3 buckets, which means RMAN can also recover directly from S3 buckets and bring it back for you, which works both ways. Okay? Security. It's a very important aspect, very important factor. What do enterprises, when they consider security, what are some of the important considerations over here? Okay? First and foremost, Amazon Web Services, as you heard in Andy's presentation this morning and everything else, has provided quite a bit of capabilities to help organizations handle internal controls, right? They built data centers in alignment with several of these internal controls and compliance regulations and policies. However, it's a joint responsibility. It focuses on the hypervisor and below. Anything above it on the application stack is a joint responsibility of the end user organization or a service provider like us who is helping organizations run the stack on there. So what it really means is that just because running on AWS doesn't mean that you're going to be fully covered, right? It still doesn't stop anybody being able to, I think I'm running out of time, doesn't stop anybody from being able to open up a database port to the public, for example, right? You still need good guidelines, good processes. It's easy and fast to be able to configure and create data firewalls using security groups and things like that, but it's still a joint responsibility. So these are different tools that our AWS has to help you meet your internal controls, and of course the different attestations that we have talked about. In the interest of time, I'm going to, I'll be happy to just answer the questions here if you're interested. I'll just, give this back to Mike. Invite Mike back on the stage and sort of finish up with the closing remarks.
Keep it brief since I think we're a little late, but long story short, we've been really happy since we went live on AWS with our EBS environment. It's been stable, it's been highly performant, it's met all our needs. The Apps Associates team has done a really good job of managing it for us. They do manage it as apps DBAs, provide all that change control, the security, the backup, all the kinds of things you'd have with another managed services provider in a traditional colo or even in your own data center. A couple things that I really like about it. The infrastructure cost did prove out to be effectively cheaper than our previous hosted environment and the other options we were comparing to before we decided to go down this path. You don't see this very often, but from when we made the decision to go with AWS to the time we went live, we actually were able to take advantage of two cost savings moves. One, some EC2 prices were reduced, but another thing we did during our test period was changed instance types. New instance types became available. They offered a little bit better performance at a good price point. So it's pretty easy. It's not nearly as hard as changing hardware in your data center. You stop the instances, you change the instance type, you start it up again. And we had, maybe 15 minutes of downtime in a test environment to make that change. So it was great. We have a few things that we do keep an eye on. Some of the concerns we had about latency, we are just using a VPC. We don't use Direct Connect yet. They haven't really been issues for us. Our users do experience good performance, or as good performance as you'll ever see from an Oracle Forms application running in a browser. It works great. There is an ETL that we run. We have our BI environment on premises. It's Oracle BI and an Oracle database. So we are doing a nightly ETL from our AWS database, our EBS database. And that's run generally well. There are a couple issues that we continue to try to troubleshoot with some connectivity. I don't actually think it's related to AWS, but it's not really been an issue. It restarts and completes just fine. The throughput on that connection is great. Things that we'll consider going forward. We likely will move our Access Manager single sign-on environment over to the cloud as well. It protects a couple things for us on premises, but it just seems like the next logical move we would take in getting things off-prem and moving them into the AWS environment. We will potentially down the road look at migrating our BI environment there as well. The data warehouse we have moves a much larger volume of data from other on-premises systems. So right now it makes sense for it to be on-prem. Down the road, when we're no longer using those in-house systems, it might be another candidate for moving over to the AWS platform. And I'm very interested in workspaces for us. I think that's a great VDI solution without a VDI infrastructure investment. There are use cases where I think we can take advantage of it already, and some for consultant desktop, contractor desktop provisioning that we are using it. But for the rest of our users down the road, running browser-based applications, running EBS that's already running in the AWS cloud, there's a good logical argument for putting your desktop there as well. So we're definitely keeping an eye on that. Happy to answer other questions. I think that's pretty much the end of what we had prepared. But thank you for coming.